Wonderful. Here we go. This is solving radical equations. A radical equation is an equation that has a variable under the radical or a variable with a fractional exponent. Radical equation is an equation that has a variable under the radical or a variable with a fractional exponent. An example of a radical equation would be something like this. I've got a radical, and I have a variable under that radical. A counterexample, which is like a non-example, would be this. Yes, I have a radical, but I don't have a variable in that radical, so that does not give me a radical equation. The variable needs to be under the radical. So kind of our process here is going to be to isolate the radical or the fractional exponent first. I'm going to raise to some power. It's going to be a very strategic power that I'm going to pick. And then I'll have to finish solving to find the variable. Cool. Here we go. So I've got this radical here with a variable underneath it. I want to isolate this first. That means I want it on the left side of the equation without anything else in the way. So I need to move the 6. So I'll add the 6 to both sides. If an equation had a square root, then to get rid of the square root, I would square both sides. This is a cubed root. So to get rid of the cubed root, I am going to cube both sides. So I cube the left side, and I cube the right side. I raise it to a power of 3. So cubed root and cubing something, taking the third root and raising it to the third power are inverse operations. Those two things cancel each other out. So on the left-hand side, I'm just left with 15x plus 1. On the right-hand side, I'm left with 6 cubed. 6 times 6 times 6 gives me 216, maybe, I think. Yes, 216. And then I just finished solving. So to get x by itself, I'll have to move the 1 first. And then divide both sides by 15. That's not reduced and doesn't go in evenly. So I'm going to go ahead and reduce it. They both end in a 5, so I know they're divisible by 5. Let's see. If I divide by 5, it's 43. If I divide by 5, I get, by 5, I get 3. So my reduced answer would be 43 over 3. Now, your calculator would tell you that also. Most calculators will give you the reduced fraction. Not all of them. And we're just going to do a whole bunch more like that with different roots and different exponents. So step 1, especially when we're handwriting on the computer, it's usually easier to tell, but it's we got to be very careful when we're writing things that we're clear about what that little superscript means, because 2 to the 4 and then square root of x minus 10 has a really different meaning than 2 times the 4th root of x minus 10. And they can look really similar, right? It's still a small number. It's still a superscript. But these are two very, very different things. So as you're writing, just be conscientious of that. The 4, if it's a 4th root, will always be tucked into this little radical right here. There would be a little bit, it wouldn't be in the radical if it was typed. It would be like more by the 2. All right, so step 1, isolate the radical. So I need to get rid of the 2. This 2 times, so to move it to the other side, I divide. All the other stuff is in the radical. The 4th root of x minus 10. So if I'm taking the 4th root, the inverse of that is to raise it to the 4th power. Whatever I do to one side, I have to do to the other to keep my equation equal. The left part is the easy part in this case. So the 4th root of x minus 10 to the 4th root and the power to the 4 cancel each other out. Those are inverse operations. I'm left with x minus 10 is equal to 2 to the 4th. Two to the 4th is a nice 16. 2 times 2 times 2 times 2. And then finish solving. All right. Those both are written, A and B are both written in radical form, and this one's written in exponent form. So while the operations are technically the same, I can rewrite something from exponent form into radical form and vice versa. It tends to trip us up a little bit just because of those fractional exponents. Two times parentheses x plus 3 to the power of 3 halves. I want to isolate what's to the power. I want to get that by itself. I'm going to leave that chunk. So to get rid of the 2, I'll just divide both sides by it. Divide by 2, divide by 2. X plus 3 to the power of 3 halves. And then I get equals 27. I'm going to go back and I'm going to talk about the example B. And I know that it was written in radical form, but let's look at when I have the fourth root of x minus 10 is equal to 2. And I raise that to the fourth power. This is equivalent to writing x minus 10 to the power of 1/4. It's just not as easy on the eyes. All right. Remember that my index becomes the denominator of my fractional exponent. We talked about that yesterday again. So when I raise this to the fourth power, right? When I raise this to the fourth power and I raise this to the fourth power, what's happening here? I have 1/4 times 4 in the exponent. When I raise a power to a power, I just multiply, which is what gives me 1. That's how the radical goes away. That's how the fractional exponent goes away. I need to multiply by the reciprocal. When I multiply by the reciprocal, I always get 1. So now we look at problem C. I have to the power of 3 halves. I need to multiply the exponent. Well, I need to raise the exponent to an exponent. And the exponent I need to pick is the reciprocal. So I have to raise both sides to the 2/3 power. Reciprocal. Because what happens here is when I have 3 halves to the power of 2/3, I multiply those. Power to a power means I multiply, and I get 1. So by multiplying or raising it to the power of 2/3, I'm left with x plus 3 on the left-hand side. Now I have 27 to the 2/3 power. Well, we practiced these things recently. Again, if I have it to the 2/3 power, I'll write it over here. Remember, the 3 becomes the index, and the 2 is the exponent. When we reviewed exponent rules, we talked about how you can choose to either take the cubed root first and then square it, or square it and then take the cubed root. I would rather make my number smaller before I make it bigger, if possible. The cubed root of 27 is 3. Okay. If you're unsure, you can always do the factor tree. the cubed root of 27. I can break out 3 groups of 3. So I just get 3. And I have 3, that's this part, raised to the power of 2, which is 9. Finish by subtracting 3. So there's a couple different new things that happen in problem C. I'm just going to pause for a moment, give you time to look it over again. Make sure you caught all the things that I used, all the tools. So the first step that I did, just to recap, was to isolate whatever's to the fractional exponent, dividing by 2. Then I had to raise it to another power. So I had to the power of 3/2. I took the reciprocal and raised it to a new power on both sides. Well, 3/2 times 2/3 is just 1. And used some prior knowledge to raise 27 to the 2/3 power. We reviewed that in 4.1. And then finish solving. Questions that I can answer on problem C. We're going to see more of it, but all right. The next one. More skills. D is the square root of x minus 3, all plus 5, and then is equal to x. There's a lot of mini skills incorporated into this lesson. An opportunity for us to sharpen. First step, subtract 5 from both sides. I have the square root. Inverse operation of square rooting is to square something. If I do it to one side, I got to do it to the other. The square root of x minus 3 squared is just x minus 3. Yay. Oh, but x minus 5 squared, that's x minus 5 times x minus 5. Remember, when you have an expression raised to a power, you always have to write it multiple times and then multiply it out. Don't try to take any shortcuts if you've got any addition or subtraction signs in those parentheses. I've got x times x is x squared. X times minus 5 is negative 5x. Minus 5 times x is minus 5x. Negative 5 times negative 5 is a plus 25. minus 5x gives me a minus 10x plus 25, and I'm going to write that all back over here. Oh, now we're left to the quadratic equation. More opportunities to practice some previous skills. When I have a quadratic equation, I always want to isolate and solve for 0. So I'll subtract. I'm going to move the x minus 3 to the other side. So minus x, here's my like term, plus 3, here's my like term. Ways to solve a quadratic equation: factoring or quadratic formula. We've spent much more time on factoring this year. When things are factorable, makes it easier. Look, more factoring, still not going away. So this problem is asking for what two numbers multiply to 28 and add to 11. Whoops, negative 11. That's important. And I get negative 7 and negative 4. It's in factored form. And then we use that zero product property, which says that if I am multiplying two things together and I get 0, then either one of the factors can be 0. So I need to go through the process of solving for x. So I get x is 7 and 4. I'm going to pause there, give you a chance to catch up, because there's a little bit more to this. Now, sometimes when I'm working out these problems, I get what's called extraneous solutions. I know we've talked about it before, but an extraneous solution is a solution for the original equation that when you plug it back in, it doesn't actually work, right? And that has to do a lot with how we change the problem by squaring both sides. So what we need to do is I need to take 7, plug it back into the original, see if it works, take 4, plug it back into the original, and see if it works. You could do this for every problem. My rule of thumb would be to do it at least for every problem that has more than one answer. So I'm going to go back to my original square root of x minus 3, and I'm going to plug in a 7 for 3. A 7 for x. And I want to know if the left side equals the right side. The square root of, let's see, 7 minus 3 reduces to 4. The square root of 4 is 2. And 2 plus 5 is equal to 7, so that one works. Yay. Let's try 4. So same process. I'm just doing a quick plug-in. Some of these are like fairly benign. You might be able to plug it, do it in your phone. Square roots and stuff, you might want to write it down on paper, really follow your work. Four minus 3 gives me 1. The square root of 1 is 1. 1 plus 5 does not equal 4. Since 4 didn't work, this is what's called extraneous. It is not part of my final answer. My final answer is only x equals 7. E is going to be very similar. I'm going to start you off and then I'm going to let you do the rest. So it's very similar. I know it's a bit of work. They get easier as you have more practice. So I'm going to go ahead and I'm going to work with you to isolate the square root, and then I'm going to let you do the rest. So E says x minus the square root of 3x minus 2 is equal to 4. I need to get this square root by itself on one side of the equation. I can't get rid of the radical until I do that. So I'm going to move the x. And one of the things that stands out as a little bit different from problem E than D is I still have a negative in front of the radical. I have to move that also. You can do that in a couple different ways. You can think of multiplying both sides by -1 or dividing both sides by -1. They're the same thing. Give you the same result. So when I multiply the left-hand side by -1, I'm just left with the 3x minus 2. And when I multiply the right-hand side by -1, I get a positive x and a minus 4. So from there, follow the steps that we did in D. And go ahead and try to solve for x. You'll need to go through the whole process, squaring both sides, multiplying out the x minus 4, solving for x, and then plugging it in. It should take you a few minutes. Hopefully you had a chance to attempt that problem. We'll go ahead and work it out now. Okay. So I have the square root of 3x minus 2. To get rid of that, I'm going to square both sides. When I square the left side, I'm just left with 3x minus 2. When I square the right side, I've got x minus 4 times x minus 4. So I'm going to take a little bit of room and I'm going to multiply that all out. When I multiply out x minus 4 quantity squared, I get x squared minus 8x plus 16. I'm going to move everything to one side. Make sure I combine it with like terms. 0 is equal to x squared minus 11x plus 18. All right. And then I factor. Two numbers that multiply to 18 and add to negative 11 will be negative 9 and negative 2. We have x minus 9 times x minus 2. Take each part and set it equal to 0. So I've got x minus 9 is equal to 0. X minus 2 is equal to 0. X is 9. X is 2. And I check and plug them both in. Make sure you're plugging it into the original. So I've got 9 minus the square root of 3 times 9 minus 2. And I want to know, is that 4? (27 minus 2). See, that's 9 minus 5 is equal to 4. And that works out. So that one's good. And then we'll try 2. 2 minus the square root of 3 times 2 minus 2 is equal to 4. And depending on your level of like how comfortable you are with your order of operations and how much you can do in your head, this could be a little less work. 2 minus 2 is equal to 4. No, it's not. Oops, I put 0. 2 minus 2 is equal to 0. It's not equal to 4. So this one is extraneous. It doesn't ask me to identify which one's extraneous, but I think it's a good thing for your notes so that you're clear why x equals 2 is not an answer. Woo! All right. Okay. So the next examples, the steps are the same, but oftentimes students feel a little intimidated by these because there's more than one variable and you're not actually going to solve for a value. You're going to rearrange the equation to solve for whatever variable they ask for. There's a few word problems in your homework that this is going to aid in. We might do one of those together. So example 2, solve the formula for n. So I'm basically going to go through my process and rearrange some stuff. All right, so solving for n. Here's my n on the inside here. I need to strategically move the 1 and the radical and the 2, but I have to use my order of operations and what I know about grouping to do that. So the first thing that you're going to do to solve for n, the first thing that I have to move is the 2. I'm going to rewrite this. So I'm going to move the 2 first. I have divided by 2 on the right-hand side, so therefore to move it, I'm going to multiply by 2. Whatever I do to one side, I have to do to the other to keep it equal. Times 2 divided by 2 cancels. Working my way closer and closer to n. Now I have a square root. The inverse operation of square rooting is to square it. So I square the left side and I square the right side. The square root of 1 plus n squared is 1 plus n. Remember, those cancel. And now I have 2a quantity squared. So I've got 2 squared, which is 4, and a squared, which I'll just have to leave as a squared. Then final step would just be to subtract 1. So 4a squared minus 1 is equal to n. And I'm really in the habit of always putting like whatever I'm looking for first. So I'm going to do n is equal to that. These questions do a really good job at just assessing, like, do you know order of operations and do you know how to move radicals and fractional exponents without requiring you to do, some of the other skills, some of the numerical things or some of the factoring or the things like that. So B is similar. I'm going to solve for n, so I got to move the m and the cubed root and the 2. But I have to do it in the right order. If you do it in the wrong order, it's not going to be correct. This radical serves as a grouping symbol. So this is grouped. I can't ever move this 2 until the radical's gone. The first thing I want to move is the m. So let's divide by m and divide by m. There's no symbol between the m and the radical, so I know it's multiplication. And I'm going to pause right here and give you a chance to try the rest on your own. See if you can do the last 2 steps without my assistance. So this answer could be written two different ways that are obvious to me. I can either do n is equal to t cubed divided by m cubed minus 2, or you can leave the t and the m in parentheses and then cube the whole fraction minus 2. Either way, they're the same. We have a cubed root, so the inverse operation is to cube it. And then I just subtract the 2. Sorry, let me move that up so you can see. And I've got some choice for you guys. Example 3, we really already did an example with rational exponents, but it's more practice. These ones look a little bit complicated, but the process is the same. Do you want to do one more? Some head nods, yeah? Okay. I think I'm going to pick to do B over A because it has an added step. So instead of doing both of them, let's do B. Solve the equation with rational exponents. And we'll do B, this one way down here. Let me move it up. So this isn't any new skills, but it's another good practice problem. Okie dokie. So we have this whole quadratic expression raised to the 3/2 power minus 14 is equal to negative 6. I need to isolate whatever's being raised to the power or whatever's in a radical. So I need to isolate this thing. All right, to do that, I'll just add 14 to both sides. Gives me 8. I have something raised to the 3/2 power. I need to get rid of that exponent. So I'm going to raise that to a power of 2/3. If I do it to one side, I have to do it to the other. When I raise a power to a power, the rule is that I multiply my exponent. So I have 3/2 times 2/3. Oh, those are reciprocal, so I just get 1. Yay. These essentially cancel. And then we can do a little figuring over here. X to the power of 2/3 is the same as the cubed root of x. I'm sorry, the cubed root of 8 squared. And you could either square it and then take the cubed root, or you could take the cubed root first and then square it. Sometimes one option works better than the other. In this case, not too different. 8 squared is 64. The cubed root of 64 is 4. Or I can do the cubed root first and get 2. 2 squared is 4. have a quadratic, so I'll solve for 0. Factor, solve, and then plug back in. The plugging in part here is a little kind of interesting looking. This will factor to x minus 5 times x plus 2. And I'm going to plug those in. Different calculators will do different levels of work here. It could be very helpful. So I'm going to go back to the original. Let's see. Instead of x, I'm going to write a 5. I have to raise that all to the 3/2 power. And I want to know, is that equal to -6? Just take it little piece at a time. So we evaluate. That 5 squared will give me a 25 in there. Minus 3 times 5 is a minus 15. $25 minus 15 minus 6. Whoops, I copied the wrong fraction. Let's try that again. Evaluating 4 to the 3/2. It's helpful for me to rewrite this because this is square root of 4 and then cubed. And 8 minus 14 is -6. So this one works. Don't assume that if you find the one that works that the other one doesn't. We're going to plug this in and the other one works also. So let's see. I've got -2 to the squared minus 3 times -2 minus 6. Ooh, I'm going to need some more room. (3/2) minus 14. And I want to know, is that -6? Did I plug that in right? (2 squared minus 3 times -2 minus 6 3/2 minus 14 equals -6. Whew. Yes. So many steps in here. Really go slow. Little pieces at a time. So I'm going to do the -2 squared, which gives me a 4. -3 times -2 gives me a +6. 4 plus 6 minus 6, that's just 4. And I just did this same exact thing, right? They end up being the same. So I don't have to think too hard. What is 4 to the 3 halves? It's just 8. Boom, this one works too. So they're both answers. All right. That wraps up the 4-4 notes. Next time we'll be doing 4-5.